3, 2, 1.
Throughout the 20th century, the Hale telescope was the world's most advanced land-based telescope of its time, but was unable to capture the most accurate images due to the distortion caused by the Earth's atmosphere. In 1946, astronomer Lyman Spitzer talked about a space-based telescope and its advantages in his paper, Astronomical Advantages of an Extraterrestrial Observatory. With the ideas from Spitzer and the astronomical discoveries of scientist Edwin Hubble, NASA set out a mission to build the first space telescope in 1983. In 1990, the Hubble Space Telescope was launched, starting a new era for scientists to explore deeper into space to discover new galaxies and stars. After the launch of the Hubble telescope, the United States Air Force was able to discover that gamma-ray explosions are caused by stars going supernova, inspiring new astronomers to discover more about stars than ever before. With this new technology, astronomers can now observe space with high-resolution photos. Hubble helped discover more of our universe than any other astronomer or piece of technology to date.
Throughout the 1900s, there were several land-based telescopes, but the most powerful one was the Hale telescope. Built in the 1930s, the Hale telescope was not finished until 1940. This land-based telescope, now up and running, can start to discover new things with visual evidence such as quasars, spiral galaxies, elliptical galaxies, and irregular galaxies. The Hale telescope uses a 200-inch curved mirror. This mirror alone was a stroke of engineering genius. The 14.5-ton mirror would be lined up to the fiber optic low coherence interferometry to view the galaxy. A mirror similar to this would later be used on the Hubble telescope. But even with a very powerful telescope like the Hale, scientists could not break through the haze caused by the dust and debris in Earth's atmosphere. This picture is taken from the Hale, and you can see that it is very unclear and blurry. That is caused by the Earth's distortion. To solve this, Lyman Spitzer thought of sending a telescope into low orbit around the Earth. In 1946, Spitzer wrote a paper talking about a space observatory. He would spend the next 50 years of his life trying to make his space observatory happen. Spitzer was a key individual to the creation of the Hubble telescope, often lobbying for both Congress and the scientific community. Spitzer also helped make its unique design.
The Hubble telescope was designed in 1970, built along with the Space Shuttle. This helped the Hubble telescope dramatically due to the fact that it was able to be built specifically with the shuttle for easy access and missions. While NASA knew that the telescope would have many upgrades available to it before the time of the launch in 20 years. This made the design of the Hubble telescope divided into sections, later to be staggered together. This greatly helped engineers because of how the telescope was launched. The Hubble Space Telescope was launched on April 24, 1990, now known as the first space telescope with one of the largest mirrors in the world with 7.9 feet diameter. It is so precise that the largest bump on the mirror is 1/800,000th of an inch, the same as the width of 2 human hairs. In order to take a picture, Hubble must be incredibly still and lock onto something that is equivalent to looking at the width of a human hair over a mile away. Almost immediately after the launch, Hubble was the laughingstock of the world. A minor flaw in the development, which caused a paint chip the size of 1/millionth of an inch, distorted the image produced by Hubble. Even with the distorted images, astronomers went to work using the Hubble Space Telescope and already finding new celestial beings. 3 years later, it was fixed during its first service mission that went flawlessly because Hubble was built precisely for the Space Shuttle. You can see a before and after picture how much it drastically changed.
Hubble also uses many other instruments to take such clear pictures. With such a powerful telescope, it takes quite a bit of power to run. It uses two blue thin solar arrays generating 2,800 watts of electricity. Hubble also has to keep constant contact with ground. NASA uses 5 satellite systems in order to bounce signals back and forth. At least one of these satellites have to be visible from the spacecraft. Also, being the first space telescope, astronomers were finally clear of Earth's distortion. With the Hubble telescope in use, many scientists had no use for the Hale telescope. It is now mainly controlled by multiple universities for experiments. With the power of the Hubble telescope, it is able to take detailed pictures of celestial beings millions of light years away. But one of Hubble's best discoveries is the potential super black hole that is in the center of nearly every galaxy. The Hubble Space Telescope takes around 1,400 pictures a second for 3 weeks straight. These pictures are later organized by a computer and given color by an artist's rendition. The pictures taken by Hubble are released to the public, causing many people to take up amateur astronomy, which greatly furthered mankind's understanding of space. Through this amateur astronomy, we have discovered many things, being from a death of a star or a new spiral galaxy.
Amateur astronomy could not have been such a success without the Hubble telescope. The STEM education program uses pictures from the Hubble telescope to inspire young minds and teach them about the cosmos by making space interesting and colorful. This is what a teacher in a STEM program has to say.
I can't take them out to outer space, but Hubble brings space into the classroom.
These programs have taught over 6 million students every year, ranging from kindergarten through high school, about space.
If I was to try and look up in space and see Jupiter, I couldn't really see Jupiter, but I could see it with the Hubble Space Telescope.
These programs have taught over 6 million students every year, ranging from kindergarten through high school, about space. Even now, Hubble is making more and more discoveries. On January 28, 2016, Hubble photographed a cloud of hydrogen called a Smith cloud. This cloud was discovered in 1960, around 30 years before the telescope was created. The scientific community could not have fathomed what it could have been capable of without Hubble. Without the records from the telescope, we would have never found out that this cloud is moving around 700,000 miles per hour and is expected to run into our Milky Way galaxy in 30 million years, potentially creating 2 million stars in the process.
The last repair on Hubble was made in 2008. With no repairs being made and the space shuttle canceled, the life of Hubble's is coming to an end. In about 8 to 10 years, Hubble is expected to have its orbit slowly decay and spiral down into Earth's atmosphere, burning up in the process. It was originally planned on being brought back to Earth and put on display, but Hubble survived longer than the space shuttle. But with the death of Hubble's leads a new generation of telescopes. We have to move on to bigger and better things, such as the next extraterrestrial telescope, the James Webb. It is being built to succeed Hubble. With many of the engineering genius used on the Hubble telescope is being used with a few modifications. The Webb was inspired by Hubble and is designed to look further, broader, and even better than before. The Webb telescope uses 18 smaller modified versions of Hubble's mirror to see infrared light and has the potential to see 92 billion light years away. The James Webb Space Telescope is being planned on launched into L2, which is a point after our moon that is a stable point of gravity between two objects. So essentially it will hold the telescope in place unless another force interacts with it. This will be 1.5 million kilometers away from Earth. This will limit the effect of the reflection from the sun and the moon and will have better chance of images. None of this would have been possible without the Hubble telescope. Without Hubble, we would have never been able to get past the Earth's distortion and view the universe for the way it truly is.